Let's work through solving this equation that involves e raised to different powers, and it also has this plus 2 at the end. If this plus 2 wasn't here, we could simply drop the bases, the e's, and set the exponents equal. But this one's a little bit more difficult because we do have the e to the x's and that plus 2. So to get started here, what I'm going to do is go ahead and move everything to one side. So I'm going to move everything to the left-hand side, so we're going to keep the e to the 2x on that side. We'll subtract e to the x to move it over, and we'll subtract 2 as well. Now the key on this is noticing that we can rewrite this thinking of this as something of the quadratic type. That first term can really be thought of as e to the x squared, because our exponent rule says that to combine those exponents together, we would multiply them. So that would be like e to the 2x, putting them back together. Next, I'm going to go ahead and bring along those next terms. All right, why I say it's something of the quadratic type is because some people teach it as if we replace the e to the x's with a w, kind of introduce a different variable. Wherever I see an e to the x, I'm going to put a w in that spot. So it'd be like w squared minus w minus 2 equals 0. Basically, if we can solve that equation on the right-hand side in terms of w, it's going to be basically the same over on the left-hand side with the e to the x's. So I think we can factor the one on the right-hand side. If we couldn't factor it, we could always pull out the quadratic formula. But I believe this will factor as w and w to evenly split those up from the w squared. And 1 and 2 to split apart the 2, I think we'll have to have a positive 1 and a negative 2 here. Similarly, on the left-hand side, we could factor this. Instead of w this time, it'll be e to the x and e to the x, 1 and 2, and very similarly, we can put a positive and a negative appropriately with the 1 and the 2. All right. You could do this work and then eventually at the end replace back in for e to the x. In truth, you don't have to use the w's. I just like doing it because I think it's a little easier to see. Now, thinking about the w case over here, normally after we factor something, what we do is we go ahead and set our factors equal to 0 and solve down. So we get w equals negative 1 and w equals 2. We will do the same thing over here on the left-hand side with our e to the x's involved. We'll set each of these equal to 0 and try to solve down. All right, so initially, very similarly, we'll move the 1 over. We'll move the 2 over to isolate the e to the x's. But now we have an extra step because we want to actually solve for x instead of solving for e to the x. What I would do is I would apply a natural log to both sides. I would put a natural log on the left-hand side and a natural log on the right-hand side. The idea being, because we have e raised to the power of x, using a natural log is going to do some nice canceling out. All right, doing the same for this other one. Use a natural log on each side. So we still have e to the x here. We still have 2 here. And that canceling out, natural log and e to a power, these are inverse functions of one another. So we're going to get x on the left-hand side in both these cases. But the thing to remember is we're not allowed to have a negative inside of a logarithmic function. So in the case where we have natural log of negative 1, this one is going to give us no solution. So the only solution we actually end up getting in this case is the natural log of 2. And those are all the steps to solve this down. If you had chosen to replace e to the x's with w's, our next step would be going from where we are here with the w equals negative 1 and going over and replacing back in with the e to the x's, and the following steps from there on down would mimic exactly what we just did. So I hope this helps out. Good luck as you're working on solving these down. Remember, you could use the quadratic formula if you weren't able to factor this. So good luck.